Okay, today we're going to talk about section 9.4, which is on linear inequalities in two variables. Now, we're going to do a little bit of a review, and don't bother to write this down if you're taking notes. Okay, don't write this down. I want to just lead into something. So, by the way, can you see my little circles back? I keep losing my circle, and then if I'll reboot, my circle comes back. Okay, review. What if I ask you to solve, and this actually comes from Math 307. What if I ask you to solve 2x plus 3 is greater than 17? What would you do to solve? Now, that's a linear inequality in one variable. Today we're going to do them in two variables with x's and y's. But what would you do to solve this inequality? Right. You would subtract 3. That would give you 2x is greater than 14. Divide by 2. And you'd have x is greater than 7. So you pretty much did everything you normally do with equations, and you get an inequality answer. Do you remember that you usually graphed these on a number line? A number line because there was just one variable, so we just needed this for graphing. You located 7. Then you had to make a decision. Is 7 included in the solution set or not? What do you think? Is 7 greater than 7? No. Now, if it had said greater than or equal to, it would be included, but it's not included. In Math 307, you used parentheses, one parenthesis. In an older way of teaching, we would have used an open circle to say it's not included. And then everything this direction is greater than 7. Do y'all remember doing that sometime in your life? All right. Now, points on this side are not solutions. The points on this side are less than 7. So once you find the point in question, the 7, then one side of it's going to be the solution, the other side is not going to be the solution. Does that make sense? One side is and one side isn't. All right, still not taking notes. But today, we're going to talk about linear inequalities in two variables. So I'm just going to write something. I'm going to make one up. What if I had, change that. What if I had y is greater than 2x minus 3? Well, it's already in the form y isolated mx plus or minus b. What if you just graphed y equals 2x minus 3? Well, if this is going to be a sketch, nothing perfect. You would begin at negative 3, and then the slope is 2. Put it over 1, that's up 2, right 1. So if I went up 2 and right 1, I'd get another point. Now, what I've done is identified, I haven't drawn it yet, but I've identified that the line is going to be coming through here. Everybody agree? Back when I did this problem, that is like me identifying that 7 was right here. The next thing I had to do was talk about, is 7 really included? Well, is this line really included as solutions to this inequality? This line says that the y-coordinate is equal to twice the x-coordinate minus 3. The actual thing I'm supposed to graph says y is bigger, but does it say it's equal to? No. So this should not be included. How do you show a line that's not included? You show it by using a dotted line. And don't worry, I'm going to give you all this information. Most of it's on your blue sheet. This was not included because the inequality symbol in the original problem was strictly greater than. It didn't say greater than or equal to, just greater than. So I needed a dotted line for a boundary. It's like an open circle. Now, on one side of this line, I'm going to have solutions, and one side, I'm not going to have solutions. Back with your one variable, one side had solutions, the other side did not. When you're in the two-dimensional setting, one side has solutions, the other side does not. How do you know which side? Well, the author of your book will have you do some testing, and I'm going to give you an easier way to do it. If y is greater than this line, it's greater than, where does y get bigger? Going up or going down? Going up. Y gets bigger going up. When you can say that, then what you do is shade the side that is above, because it said y is greater than. Every point on this side is a solution to this inequality. Every point on this side of the dotted line is not a solution. You could even check that if you wanted to. And some of your math lab questions are going to have you check things. For instance, if I wanted to check the point, and I'm going to test the point 0, 0. Why did I pick 0, 0? I saw that it was a point in the shaded region. And it's a nice, easy point to work with. X is 0 and y is 0. So if I have y is greater than 2x minus 3, and I plug in 0, 0, 0 for y, is that greater than 2 times 0 minus 3? What's 2 times 0?
0.
And 0 minus 3 is negative 3. Is 0 greater than negative 3? Yes, that's true. Any point, if I picked any point in the shaded region, it will test out to be true in the inequality. What do you think will happen if I pick a point on the unshaded side? It will be false. This side is all true. This side is all false. But how did I decide which side to shade? If it said greater than, I shaded above. If it had said less than, I would have shaded below. And it's that easy, and it always works. So, with inequalities with two variables, we deal in a two-dimensional setting, and we have shaded regions. Unlike inequalities in only one variable, where we only have one dimension, we have a side that's shaded, a ray. Okay? So what we're going to do today is work with these kinds of inequalities. Okay? So if you have your notes printed, you've got something to graph on. If you've got a straight edge and any colored pens, highlighters, whatever, that will be great. And for those of you who need it, let's take a look at the inequalities. The first two questions, and I'm not going to do all of both of these. I'm actually just going to do part of each of these numbers. Excuse me. Each of these ask you to do a little bit of practicing determining whether a point is a solution. So, problem number 1. It starts out with y minus x is greater than 2. And it has two parts to it. We're only going to do one of them. If I do the first one, it says, is the ordered pair 0, negative 2 a solution? Well, I need to plug in x is 0 and y is negative 2, and then just see if I have a true or false statement. So I have negative 2 minus 0 greater than 2. Simplify the left-hand side of that. Negative 2 minus 0 is negative 2. Is negative 2 greater than 2? No. That is a no, which means it's not a solution. what this would relate to if you were doing a graph is if you had this inequality graphed, the one that I'm highlighting right now, if you had this graphed, you would have concluded that the point 0, -2 is not a solution. What you get to believe from that is that any other point that's on the same side of the line with 0, -2 is also not a solution. All the solutions are together on one side, everything on the other side is not a solution. All right, you have a second part to that we're going to skip. We're going to go to question number 2. Question number 2 says determine whether these points are solutions. The inequality that I'm given is 2x plus 5y is less than or equal to -2. And I'm supposed to test the point -1, -2. So x is -1 and y is -2. Plugging those values in. That's 2 times -1 plus 5 times -2 is supposed to be less than or equal to -2. Let's see. 2 times -1 is -2. 5 times -2 is -10. Combine those for -12. Do y'all agree that the left-hand side's value is -12? Is that less than or equal to -2? Yes, because the more negative you are, the smaller you are. So the answer here is a yes. That is a solution point. If you had this inequality graphed, then you would shade the side that contained the point -1, -2. Because if it is a solution, then all points on its side are also solutions. Now, the author of your book believes that this is the way you ought to find out which side to shade. Test a point. It works beautifully. But I'm telling you that you really don't have to do that. We're just going to remember that if the statement says greater than, we're going to shade above. And if the statement says less than, we're going to shade below. So, are y'all ready to move on? Understand the testing of points, even though we're not going to use it much. Let's look at problem number 3. This problem says, graph the following inequality. It is x plus y is greater than or equal to 4. I'm going to choose slope-intercept as my method for graphing. So I'm always going to get the y isolated, and furthermore, I'm always going to get the y isolated on the left-hand side. So I'm going to keep y by itself, and I'm going to subtract x from both sides. That's y is greater than or equal to -x plus a 4. Right now, I want you to, greater than or equal to. I want you to take a look at the inequality symbol. And I'm going to go over here and draw a conclusion. The symbol says greater than or equal to. Because it says equal to, when I graph the line, is it going to be solid or dotted? It's going to be solid because equal to is included. It's going to be a solid line. It's got a greater than. Since y is greater than this, will I shade above or below the line? Above. So for every problem that I do, I'm going to get the inequality with the y on the left isolated. I'm going to look at the inequality symbol. If it has equal with it, I'm going to write solid. If it does not have equal with it, I'm going to write dotted. If it is a greater than, I'm going to write above. If it's less than, I'm going to write below. All of that information is on the back side of your little note sheet. Okay, it is all on there. Now, I'm going to graph this. I'm going to ignore the fact that this is an inequality symbol. I'm going to think about the line. And where would I begin? What is the B value? The B value? 4. And what's the slope? What's the M value? That is -1. I'm going to put it over 1, so it is down 1, right 1. I have all the information I need. I know what kind of line to draw, solid. I know where to begin. I know how to move. And then I know which side to shade. So let's take a look at this grid. All right, I'm going to begin at 4. I'm going to move down 1, right 1. Use a straight edge. You told me that I needed a solid line. And now, you also told me to shade above it. So I will pick one of my colors and I will shade above it. I actually enjoy a day when I get to color, so it's good for me. What does that tell you graphically? It says that if you picked any point in my turquoise shaded region, any point at all, and you plugged its x and y in to the original inequality, it would be true. Every point in this region is a solution. What does it tell you about every point that's not in that region? It's not a solution, and it will be false if you plug it in. There's always a true side and a false side. Is everybody kind of okay with that? All right, now I'm going to try to go, it worked. I have just gone over to my math lab. So I am in a live version of my math lab. And I am not going to be able to write on this because I'm not in a program that allows for writing, but we are going to try to solve this. So would you take a moment on your paper and take 2x plus 4y is greater than -4. Let me say that one more time for you. 2x plus 4y is greater than -4. Get it in the form where it is solved for y. Okay, using the MathLab tools, I'm going to use the line tool. And notice down at the bottom that you have a choice of dotted or solid. Let me enlarge this just a second. Okay. I'm going to, come back here. All right, I'm going to, stay there. I'm going to use the line tool. I'm going to use a dotted line. So everybody got that? That's where you choose that. I'm going to begin at -1, and I'm going to move down 1, right 2, and click my other point. So this time it's just like graphing the lines that you did back in a previous section, but now a dotted line. Now what if you had the wrong one chosen? At any time you can go in and change it to solid, change it back to dotted by clicking back and forth between those two. Now it's time to shade. Y'all told me in class that it was going to be a dotted line because it was strictly a greater than symbol, and it was going to be shaded above. To shade in this, you're going to use the little paint bucket. There is a little paint bucket. You've probably all used programs sometime that have used the little paint bucket. So click on the paint bucket, go to the side, and you can see your little icon is a paint bucket. Click over there, and it will shade the side where the paint bucket was. So dotted line, shaded above. Because I used the enlarged version, I had to hit save, and then it's off screen, but I'm telling it to check my answer, and it was happy with me. Okay, so is everybody okay with dotted versus solid lines and how to shade the side you want shaded? Okay, then let's go back somewhere. Okay.
I have a question.
Yes.
So if it is solid, less than, regular less than, greater than is solid.
Exactly the opposite of that. If it has an equal with it, then it's solid. And let's just write that down somewhere. Let's put it right up here. If we have a greater than or a less than, it's going to be dotted. Am I on the screen? Yes. If it is greater than equal to, less than or equal to, it's going to be solid. Okay? And that information, once again, is on the back of your note sheet. Let's look at another problem. Problem number 5. I have x plus 2y is less than or equal to negative 2. The first thing I do is get y by itself. So what am I going to need to do? I need to subtract x. So 2y is less than or equal to negative x minus 2. Divide by 2. And that gives me y is less than or equal to. Now, taking a look at the term that has the x, do you agree that the coefficient up there on top of the x is really a negative 1? Which means that I'm going to write the fraction negative 1/2 x, and then somehow I've lost my underline there, and minus 1. So the coefficient of x is the negative 1 that's on top and the 2 on bottom. The constant is negative 2 divided by 2. Let's say everything we need to say based on this symbol. Solid or dotted? Solid. Will I shade above or below? It is a less than. Where does y get less? Below. Remember that y is your up-down variable. It's your vertical variable. So if y gets less than something, it goes down. Where will I begin to graph the line part of this? At negative 1. And the slope is, I have put the negative sign with the numerator, so it's negative 1 over 2, which is down 1, right 2. And once you have that information, then I will enlarge the graph for those of you in the class. All right, I'm going to begin at negative 1 on the y-axis and put a point. From there, I will move down 1, right 2, and put another point. If I were doing Math Lab, that's absolutely all it would take for me to get a line, and I would need to make sure that I've chosen solid line. You indicated to me that we needed to shade below this line because y is less than this, so I will shade this bottom part. You, of course, will just use your bucket. So pretty. Okay, are you having a good time coloring? Only a few of us are. The rest are thinking we're goofy, but I remember the good old days of coloring. What you have is a visualization of all the points which are solutions to the original inequality. All right, I want to skip, let's see, I already skipped one. I didn't intend to do that. Okay, I'd like to go back now and do number 4. So I'm not sure why I did that. I skipped from 3 to 5. All right, this is number 4. The inequality is x minus 2y is greater than negative 10. And I specifically want to do this one because there is something we need to make sure we talk about. All right, if I'm going to graph this, what shape do I need to get this inequality in? I need it y isolated. So I'm going to subtract x. I have negative 2y is greater than negative x minus 10. What am I going to divide by? Negative 2, and then hold up a minute. All right. Does anybody happen to remember what happens to an inequality when you divide both sides by a negative? It reverses the inequality symbol. So this symbol reverses whatever it was, it flips over. So I'm going to have y is now less than, all right, the coefficient of x. I've got a numerator and a denominator. I've got a negative 1 over a negative 2. I'm not going to leave it negative over negative. I'm going to write it as positive 1/2 x. Then I have negative 10 over negative 2, which is positive 5. I hope it's very obvious to you that if you neglect this rule of inequalities, you'll shade the wrong side. Anytime you divide both sides of an inequality by a negative number, the inequality symbol reverses. It's the only time. All right, everything we ever wanted to know about this. It has just less than. Is that going to be a dotted or a solid line? Dotted. It says less than. Will that be above or below the dotted line? It will be below. Where will I begin to graph this line? At 5 on the y-axis. The slope is written as positive 1/2, which is up 1, right 2. And with that information, I should be able to complete the graph of this inequality. Okay. All right, I'm going to begin at 5. I'm going to go up 1 and right 2 to get another point. Use a straight edge. And I'm supposed to shade, you told me, below, because it was a less than. Oh, it was supposed to be dotted. Thank you. Let me see if I can make it become dotted. Not very well. Okay. I didn't pay attention to what I had written down. I was supposed to have a dotted line. I just jumped right in there and drew a solid line. And I'm guilty of that more often than I would like to admit. And if I have an audience to catch it for me, I'm okay. Otherwise, I have to be really, really more careful. No, that didn't work. Okay, we'll just ignore that little black blob in there. Okay, so much for coloring. I got so wrapped up in picking my purple and doing my coloring, I forgot to do a dotted line. Is everybody okay with the process? All right, so one thing you want to be super careful about is when you are getting y by itself, if the coefficient of y is a negative number, you're going to divide by a negative. It's going to cause the inequality symbol to reverse. So watch out for that. We've done 5. 6 and 7 are multiple choice questions. If I were you and working on those, I would graph the inequality or get all the information on my paper, and then simply look at these. Now, it looks as if you have they all have the same line. But some of the choices have dotted lines and some of them have solid. Some of them have shaded below and some of them have shaded above. So you're going to want to take the inequality, say 5x plus 5y is greater than negative 10. You're going to want to solve it for y. So subtract 5x, subtract 5x. 5y is greater than negative 5x minus 10. Divide by 5, and I'm running out of room. And for number 6, I get y is greater than, y is greater than negative x minus 2. All right, there's my inequality. Will it be a dotted or a solid line? It will be dotted. Now, those of you in the classroom might be having trouble reading from your distance, but choice A is a solid line, so it can't be right. Choice D is a solid line, so it can't be right. Now, it's a greater than. Greater than tells you will shade which way, above or below? Above. The only one that is dotted, shaded above, is choice B. And so I might just double check, does it cross the y-axis at negative 2? Is the slope negative? Yes to all those questions. So B is definitely the correct answer.
So we begin at 2, negative 2?
Uh-huh. And it is down here, it's counting by 2's, but it is starting at negative 2. And then if you went up 1, if you went down 1, right 1, you'd be back on that dotted line. So it is choice B. So do that with numbers 6 and 7. And let's take now a minute to look at number 8. It is a little bit different. What's different about number 8 is that it doesn't have a y in it. It just has x is less than or equal to negative 5. Now, what does the graph of x equals negative 5 look like? What kind of line is it? It's a vertical line. So if I were going to graph this, I have to be thinking in terms of a vertical line. Now, let's go ahead and talk about the symbol. Will it be a dotted or a solid vertical line? It will be solid. Now, if I have a vertical line, does it make any sense to shade above or below a line that is running up and down? Not really. So let's go ahead and get that line in there. X is equal to negative 5 is a solid line right through here. My statement says x is supposed to be less than this line. Which side does x get less? Left or right? Left. So for a vertical line, there is no more concept of above and below, but instead only to the right or to the left. So this was a solid line, and we will be shading to the left of the vertical line. This information is also on your blue sheet on the back. So the solid and dotted part, still appropriate, but you do have to think in terms of less than is to the left, greater than is to the right. Let's look at number 9. It says graph the following inequality, and this time it is y is less than or equal to 3. What does the line y equals 3 look like? It is a horizontal line. And if you'd like to, we could go, well, tell me please whether I'll be drawing a vertical, will I be drawing a dotted or a solid horizontal line? It will be solid. So I'm going to go to y equals 3. Draw that line. Since it is a horizontal line, can I be talking about above and below it? Yes, I'm back, and that's appropriate to talk about that. The symbol says less than or equal to. So is it above or below? Below. So I will shade below that horizontal line. And every point in the yellow region has as its y coordinate a number that is less than or equal to 3. So the slanted lines, you're going to use y equals mx plus b. Vertical lines, you just have to remember that if it's less than, you shade to the left, and if it's greater than, you shade to the right. Horizontal lines, greater than, shades above, less than, shades below.
In these particular problems, they time it's x, and x equal. If x equal to something, is a horizontal.
It's vertical.
Vertical.
And if it's
y equal is
horizontal. Yes, ma'am. So we're going to look at number 11, which is graphing the solution of a system of inequalities. A system. What that really says is you're going to graph two inequalities. These inequalities are already in nice forms for you. We have y is less than 4x minus 3, and we also have y is less than or equal to x plus 4. For the first one, it has a less than. Is that going to be dotted or solid? It's going to be dotted. Will I be shading above or below that line? Below it. Where will I begin? At -3. And how the slope is 4, so it's up 4, right 1. So I have to accumulate all that information. And when I do that one, I will do it in pink. The second inequality, is it dotted or solid? It is solid because it has equal with it. It has a less than, so will you shade above or below? Below. And where will I begin? 4 on the y-axis. The slope is 1, so put it over 1. That's up 1, right 1. And I will do it in yellow. Now, if you use the same colors, then what will happen, the intersection of the shaded regions should turn sort of orange. If you use blue and, I wonder if blue and yellow would be better. No, it doesn't matter. Okay, getting too carried away with my colors here. All right, let's see what happens. This information for those of you in class is going to disappear because I've got to focus on the grid. All right. The first one, I begin at -3. I move up 4 and over 1. And I draw, and I'm remembering, a dotted line. And I'm going to shade below it, and I'm going to use kind of a pink. And like I said, I don't really know if these colors will blend nicely. Anybody have a question about the first one? All right, second one, I have a solid line that begins at 4. From there, I go up 1, right 1. Draw a solid line. Shade below it with a different color. Oh, yes. Very nice. I'm kind of excited. This did better than my markers. Back to seeing y'all. So I'm doing two completely distinct problems, but I'm doing them on the same grid. Every point that was shaded yellow was a solution to the second inequality. Everything that was shaded pinkish purple was a solution to the first inequality. And where there is an intersection, the colors changed. And so I have a brilliant reddish orange. Every point in this region, all of these points, are solutions to both inequalities. If you happen to be going into business and the math courses that you take are what are called business eco-analysis, the second, well, no, I think it happens in the first course. You do a lot of graphing of these inequalities. You get feasible regions. And so you will do a good bit of this in that class. You can even get the TI graphing calculators to do this shading for you. Anybody have a question about systems? I'd like to take a minute to show you how would you do this in MATLAB. Well, I actually learned how to do this in MATLAB during my last class. Unfortunately, you don't get to do the pretty merging of colors. This is problem number 11 in my MATLAB, so I want to show you what it's like to do it here. I can't write all the things down on this screen any longer, so we're going to have to just kind of remember things. The first inequality, y is less than 3x minus 1. It's less than. So it will be a dotted line. It will begin at -1. It will go up 3 and right 1. So I'll do all those things. It's got to be a dotted line, so I just click dotted. And it is a line. So I begin at -1, leave a point there, go up 3, go right 1. I've got my dotted line. Don't shade. Okay, I learned this the hard way in my last class. I assumed it would shade it one color, and then when I did the second one, it would shade it another color, and that's not what happens. Don't shade yet, but hold in your mind you're going to shade below. Go to the second one. Second line. This one is solid. I'm going to begin at 5. I'm going to go up 1, right 1, and it gave me my solid line. Now, for the first one, I'm shading below. That's below the dotted line. For the second one, I'm shading below the solid line. Do y'all agree that the region I'm bounding right now with this little red circle, here to down here, all of this is going to get shaded twice. All of this region is below the dotted and the solid line. So what you do is pick your bucket, go into that region and click, and it is the part that is below the solid line and below the dotted line. So you don't shade both of them, waiting for a color to merge. You just isolate in your mind the region you want shaded and go in there and click. And so you can see that if I check my answer, it's happy with me. And it took me missing a problem to get it right. I did it wrong, and then I went back. And looking for an example does not help. Looking at an example, because it doesn't tell you how to use the tools. I'm sure there is a way to find out about that, but for y'all, that way is I just showed you.
So all the time it's going to be the 2, or you're going to shade the 1 that's below both?
Not always. Let's see. Let's look at number 12. Okay, it's worth it to do this. If I look at this one, the first one is y is less than or equal to -3x minus 3. So solid line, solid, begin at -3, go down 3, right 1, solid line. I will be shading below that. Just kind of hold that in the back of your head. New line. This one is also solid. Okay. I begin at 2. Whoops. No. Oh. I'm thinking bad things, but I'm using self-control.
I start burning at home, things start happening.
Okay. You feel my pain. All right. The second one, I'm going to start at 2, not at 1, and I'm going to go up 1, right 1, and there's my second line. Now, The first one, I was supposed to shade below the yellow line. The second one, I'm supposed to shade above the blue line. So, below yellow, but above blue. Can you visualize which area got double shaded? Below yellow, but above blue. This region got double shaded. So that's it. And you might physically have to draw it on a piece of paper and do some shading and go, oh yeah, this part's going to be the overlap. So it was above this one and below this one, so it's right there. Check my answer. Oh, never mind. Okay, maybe I just did I just do that backwards? We'll try again. Less than the 3. Oh. Well, there's nothing like demonstrating wrong. All right, less than this one and greater than this one. So it looks like it's probably this piece. Well, how do I undo that? Are you really feeling my pain? For those of you watching this video, I'm showing you what it's like to mess up.
What would it have done if we had pressed the delete button?
The delete button? Probably something a whole lot better than what I just did. Okay, let's,
I didn't see it until after you'd already done it.
okay, let's select a tool. All right, I'm doing this one more time just to demonstrate perseverance. -3. Yes, this is, all right, now, if I hit delete, well, it made the whole thing go away. I'm getting pretty good at this one. I know what it looks like. All right, the other one, line, solid, 2, up 1, right 1. There we go. All right. Now, make sure I don't do it wrong again. The first line is the blue line, and I am shading below it. All of that. The second line is the yellow line, and I am shading above it. This is the double shaded region? Okay, everybody's giving me a head nod. I'm pretty sure that one was right. I think I was just pointing to the wrong line when I was saying above this and below this.
So it's the double shaded areas that get.
It's the double shaded area is the only area you shade. It's as if you magically knew where the intersection was. Okay? So it's a little bit of a challenge in my math lab. How many problems do you have? You have 3 that are intersections. Okay, would you like to do one more intersection? Okay. Let's look at number 12. This will be our last one. If I have enough room, we have y is less than or equal to -3x minus 3, and we have y is greater than or equal to x plus 5. Luckily, with these problems, you don't have to get them solved for y. They already have that. So, dotted or solid for the first one? Solid. Above or below? Below. Where will I begin? -3. The slope is also -3, but put it over 1, down 3, right 1. And I will do that in blue. Second line, solid or dotted? Solid. Above or below? Above. Where will I begin? And the slope is an implied 1, so it's up 1, right 1. And I will do it in yellow. Okay. Both of them are solid. That's good. All right, I'm going to begin. At -3. I'm going to move down 3, right 1. Draw a solid line. And I'm going to shade with blue below. Second line, I'm going to begin at 5, and I'm going to go up 1, right 1, draw a solid line, shade with yellow above. Does everybody see that the overlap turned green right here? So if you were doing something like this in MATLAB, you would have to be thinking about, okay, I am below this line, I am above this line, where did those two regions overlap? And it was this little piece over here. Yes, ma'am? Mm-hmm. Okay, let's go back to that one. Is everybody okay with the systems? Okay, there was a request to go back to number 10, and it really is a good question. So I'm glad you ask about it, and your fellow students will be glad that you ask about it when they start to do this question. Now, it starts out, it looks super, super easy, and it will be, but there's a little kink to it. It's x is greater than y. The way I've been talking about the inequalities with the y's, I have to have y written first because I'm saying, is y greater than this or is y less than this? I'm talking about it from y's perspective, which means that I really need this inequality turned around. I need y on the left. So if I put y on the left, if x is greater than y, then doesn't it hold that y is less than x? I have to turn the entire inequality around. Now, if I want to graph that line, first of all, based on that symbol, will it be dotted or solid? It will be dotted. Will I shade above or below? Below. Because from the y's perspective, y is smaller than, so it's below. And where will I begin? What's the b value? Now the b value is an implied 0. It's the identity for addition. What is the slope value? That's your 1. Both of those were implied. Neither one of them was written. So it's 1 over 1, which is up 1, right 1. So there were several things about this problem that are worth talking about. So I begin at 0. I go up 1, right 1. I draw a dotted line without a straight edge this time. I shade below it. And that's what my graph looks like. You want these inequalities, if they have a y in them, then the y needs to be on the left-hand side. Turn the entire statement around if it's not. Is that okay? I'm glad you asked about that one. All right, 9.4 is finished. That's all we do in our combined chapter of 3.6, 8, and 9.